Hello everyone. Today we will going to see some practice questions from the topic redox reaction, and this is part 3. Let's start. Disclaimer, which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the image. So this is a index slide, and we will going to see some practice questions from question number 16 to question number 21. Let's start with the question number 16. In which of the compounds does manganese exhibit highest oxidation number? We have given manganese different compounds on the options. We have to tell in which of the compound the manganese exhibit the highest oxidation number. Options are MnO2, Mn3O4, K2MnO4 or MnSO4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is K2MnO4. So highest oxidation number of manganese in K2MnO4 is, K will be +1, so 2 times 1 will be 2, plus Mn will be X, and oxygen is -2, so -2 times 4 will be -8 is equals to 0. So X is coming out as X is equals to +6. While in all the other compounds in the options, oxidation number of manganese is lower than 6. And so the K2MnO4 exhibiting the highest oxidation number of manganese element, and thus the correct option is C option. Okay, let's move to the next question. Question number 17. Which order of compounds is according to the decreasing order of oxidation state of nitrogen? We have to tell the decreasing order of nitrogen oxidation state. Options are the lowest in N2, then NH4Cl, then NO, and highest in HNO3. Highest in HNO3, then NO, then N2, and then lowest in NH4Cl. Highest in HNO3, then NH4Cl, then NO, then lowest in the N2. Highest in NO, then HNO3, then NH4Cl, and then lowest in the N2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option B, that is HNO3, NO, N2, NH4Cl. So let the oxidation number of nitrogen be X. Actually, this is the order, right? So it will come like this. Highest in HNO3, then NO, then N2, then NH4Cl. So let the oxidation number of nitrogen be X. Now let's find out the X in every compound. In HNO3, H will be +1, X for nitrogen, and 3 times -2 for oxygen is equals to 0. So X will be coming out as +5. In NO, X is for nitrogen, -2 is for oxygen, X -2 is equals to 0, X is coming out as +2. In N2, as N2 is in elementary state, so X will be equal to 0 for this. And in NH4Cl, the nitrogen will be X, hydrogen will be +1, so 4 times 1, and chlorine will be -1, so -1 is equals to 0, and on solving it for X, X is coming out as -3. As you can see that the highest oxidation number for the nitrogen is in HNO3, then it will be in NO, then N2, and then lowest in the NH4Cl. Thus, the order of oxidation states of nitrogen is highest in HNO3, then nitrogen oxide, then N2, and then NH4Cl. Thus, option B is the correct answer. Let's move to the next question, question number 18. Oxidation states of metal in the minerals hematite and magnetite respectively are. As hematite and magnetite are the iron compounds. Okay, so we have to tell the oxidation states of the metal in the mineral hematite and magnetite. Options are second, third in hematite and third in magnetite. Second, third in hematite and second in magnetite. Second in hematite and second, third in magnetite. Or third in hematite and second, third in magnetite. So you have 10 seconds to solve this question. After that, we will see the answer. The correct answer is option D, that is third in hematite and second, third in magnetite. So hematite is Fe2O3 and in which oxidation number of iron is +3. So if we calculate, let's suppose Fe is having X. Okay, so 2 times X and oxygen is having -2. So -2 times 3 will be -6. So 2X minus 6 is equals to 0. Now x will go, 6 will go, -6 will go to the right hand side. So 2x is equals to +6 and x will be equal to +6 divided by 2, which is 3, right? So in the hematite, the iron oxidation number is +3 and magnetite is Fe3O4, which is in fact a mixed oxide of FeO and Fe2O3. And hence the iron is present in both second and third oxidation state, because Fe2O3 we just find out it is in 3 oxidation state, +3 oxidation state, and in FeO, O will be in -2, so X -2 is equals to 0, X will be +2, so iron oxidation number in the FeO is equals to 2, right? So 2 and 3 in the is the oxidation state in the Fe3O4 and +3 is the oxidation state in Fe2O3, that is hematite. Thus, the option D is correct. That is third in hematite and second, third in magnetite. Okay. Let's move to the next question. Question number 19. The oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium dichromate solution is. So we have to tell the oxidation state of chromium in the final product, which is forming by the reaction between Ki and potassium dichromate in the acidified solution. Options are +3, +2, +6 or +4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is +3. So this is the reaction between the Ki and the acidified potassium chromate solution, a potassium dichromate. So Cr2O72 negative plus 14H positive plus 6I negative. We are writing the reaction in the ionic form, balancing the reaction by equating the numbers as stoichiometric coefficients to balance the atoms or ions present in the both side. So Cr2O72 negative plus 14H positive plus 6I negative, giving us 2Cr3 positive plus 7H2O plus 3I2, right? So Cr2O72 negative is reduced to Cr3 positive, right? Like here, Cr2O72 negative reducing to 2Cr3 positive. Thus, the final state of Cr, that is chromium, is plus. And what we have asked? We have asked that in the final product of the reaction between Ki and acidified potassium dichromate solution, what is the oxidation state of chromium? So in the final product, the oxidation state of chromium is +3. And thus option A is the correct answer. Okay, let's move to the next question. Question number 20. Oxidation state of sulfur in anions SO32 negative, S2O4 2 negative, and S2O6 2 negative increases in the order. Again, we have to tell the order of the oxidation states of sulfur in these three anions. Options are the most in SO3 2 negative, then S2O4 2 negative, then S2O6 2 negative. Most in S2O6 2 negative, then S2O4 2 negative, then SO3 2 negative. Most in S2O6 2 negative, then SO3 2 negative, then S2O4 2 negative. Or the most in SO3 2 negative, then S2O6 2 negative, then S2O4 2 negative. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see the correct answer. So the correct answer is option C, that is the most in S2O6 2 negative, then SO3 2 negative, then S2O4 2 negative. So let's suppose the oxidation state of sulfur be X. So we have to find out the oxidation state of sulfur, that is X value, in all of these three ions. So in the SO3 2 negative, X is for sulfur plus oxygen is in -2 state, so -2 times 3 is equals to -2 because the overall charge present on the SO3 is 2 negative. And it will be X minus 6 is equals to -2 and X, therefore X is coming out as +4. Okay. Next, in the next anion S2O4 2 negative, X is for sulfur, so 2 times X plus -2 is for oxygen, so -2 times 4 is equals to -2. Okay. Now let's solve it for the X. It will be 2X minus 8 is equals to -2. 2X is equals to 6 or X is equals to +3. Okay. So oxidation state of sulfur in the S2O4 2 negative is +3. Now in the last S2O6 2 negative anion, 2X for the sulfur plus -2 times 6 for oxygen is equals to -2 as overall charge is -2. Let's solve it for X. So 2X is equals to 10. X is equals to +5. You can see that highest oxidation number for the sulfur is in S2O6 2 negative, that is +5. Then it is in SO3 2 negative, that is +4. And then it is in S2O4 2 negative, that is +3. So this is the correct order. Therefore, the increasing order of oxidation states is most in S2O6 2 negative, then SO3 2 negative, and then SO2O4 2 negative. So this is the increasing order of oxidation state of sulfur. And thus the C option is the correct answer. Let's move to the next question. Question number 21. 6 moles of Cl2 undergo a loss and gain of 10 moles of electrons to form two oxidation states of chlorine in an auto-redox change. So auto-redox change, if you don't remember, is a redox reaction in which same element is undergoing oxidation also and reduction also. So what are the two oxidation states of chlorine in this change? So we have to tell that when chlorine undergo oxidation as well as reduction, what is the oxidation state, two oxidation states of chlorine in this change? Options are +5 -1, +7 -1, +3 0, or +3 -1. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. The correct answer is option A, that is +5 -1. So, as I said that in the auto-redox change, both the reaction is happening with the same element, that is oxidation and reduction, right? So Cl2 on oxidation, it gives 2Cl plus 10 electron, and the Cl in the 2Cl is in +5 oxidation state. Okay. Similarly, in the reduction, 5Cl2 plus 10 electron giving us 10Cl minus, and the overall redox reaction will be Cl2 giving us 2Cl plus 10Cl minus. Thus, the Cl is having a +5 oxidation state in this compound and -1 oxidation state in this compound, that is 10Cl minus, right? And that's why the two exhibiting oxidation state of chlorine will be +5 and -1. Okay, the option A is the correct answer. Okay, thank you.